Okay, what we're being asked to do right here is we're trying to find the zeros of this function. Now, we've been finding the zeros of the function in various forms by finding the intercepts, completing the square, factoring, or quadratic formula. But this is in a form where it's in vertex form. Now, the transformations of the functions, which really helped us to graph, can help us decide if our answer is going to be reasonable or not. So let's take a look from a transformation process to understand what would make sense for our answers when we actually do go and solve and find the zeros. So if we were thinking about this graphically, every piece of the equation controls some kind of a movement. Now, with anything behind the function is going to control up-down movement. So this is going to be a +4 in our movement, and anything inside the graph is a left-right. So the -5 actually moves us to the right 5 units. Anything up front will actually change our stretch or shrink. So this controls whether it gets skinny or widen. Anything greater than 1 will make it skinny, and anything that a negative in front will actually reflect. So these things are to tell us where our graph is going to end up. Now, our quadratics are in that U or parabola shape, and I like to do like a little hook 'em horns of our normal function would start off here, but it's going to be moved up 4 to the right 5. It's going to be reflected and then stretched. So to get an idea, I'm going to be looking somewhere like this. The goal is not to graph it precisely. The goal is to get an idea of where the graph is going to be. So if I'm looking for my zeros, I can see that both of my zeros, my x-intercepts, have to be positive, and this graph is going to accelerate down. So my y-intercept is going to be very, very far down the graph. Okay, so a large negative value would make sense because of how we know the graph is going to, the shape is going to graph. Now, let's take a look at the process. We know we can, in this form, it's the vertex form. We've already done most of the work for completing the square, so we're going to use that version for solving. So what I'm going to do is I'm going to replace this with a 0. And we're going to try to solve for the values of x. The values of x that will give me a 0. And those are going to be our x-intercepts. So the first thing I'm going to do is actually going to add or move this portion over to the other side. And now we're going to have +2 times x minus 5 squared equal to 4. We can divide this and isolate the quadratic. And now I can take the square root of both sides. And when I'm taking a square root, I'm going to have a positive and negative case. So we're going to have the plus or minus √2. And then we'll add 5 to both sides. So 5 plus or minus √2 are going to be our zeros. And that should make sense. Now the square root of 2 is a little bit more than 1. It's about 1.4. So we're saying 5 minus a little bit more than 1 and 5 plus a little bit more than 1. Now, both of those would still lie on this side of the x-axis and make sense as reasonable solutions. Now, when we're trying to find the y-intercept, we're going to set x equal to 0 and solve. 0 minus 5 is -5, and -5 squared is +25. Okay? +25 times -2, that gives me -50. Plus 4, we're now looking at -46. So when x is 0, y is at -46 for our y-intercept. And over here in coordinate form, 5 minus √2 comma 0 is the left-hand root, and 5 plus √2 is the right-hand root. And since the answers match what we were expecting, we know by using transformations, we can be very confident that we solved it correctly.